This video is a general step-by-step guide for running the Acro Biosystems human Th1/Th2 cytokine kit. We are running human Th1/Th2 cytokine kit to quantitatively determine 6 different cytokines including IL-2, IL-4, IL-6, IL-10, tumor necrosis factor alpha type, and interferon gamma in serum, plasma, or cell supernatant. Protocol information is available at www.acrobiosystems.com. Just type Th1/Th2 cytokine in the search bar and refer to the datasheet file on the website prior to use. The first step in the operation process is the calibrating. Reconstitute with 500 microliters of DI water to get a 10 microgram per ml of calibrator stock number 1. Dissolve at room temperature for 15 minutes and gently mix to ensure complete dissolution. Based on our manual, you will need to prepare 1x assay buffer. Aspirate 20 milliliters of the 2x assay buffer. Mix with 20 milliliters of deionized water to make a 40 milliliter 1x assay buffer. Mix gently. When preparing the washing buffer, use a test tube with a screw cap and add 3 milliliters of the 10x wash buffer to 27 milliliters of DI water to make a 30 milliliter 1x wash buffer solution. Mix gently, then the reagent is ready for use. Next step is to prepare the bead suspension working solution. Transfer 4.8 milliliters of the 1x assay buffer into a new 15 milliliter microcentrifuge tube. Vortex the bead suspension rigorously for no less than 30 seconds. Immediately transfer 40 microliters of each bead to this microcentrifuge tube one by one. Then the bead suspension working solution is ready for use. Finally, we need to create the standard curve. First, you will need to add different volumes of 1x assay buffer into each tube. Check with the instruction manual to make sure the volume is correct. Take 100 microliters of the 10 microgram per ml calibrator stock number 1 to the first tube. To prepare a solution with a concentration of 1 million picogram per ml. Mix liquid by repetitive pipetting. Afterwards, take 100 microliters of the 1 million picogram per ml reagent to the second tube to prepare a solution with a concentration of 100,000 picogram per ml. Gently mix. For the subsequent tubes, follow the diagram to perform the corresponding calibrator dilution. Spend some time thinking about how to set up your plate. Add 30 microliters of the calibrators and your samples to the plate. Then, add 120 microliters of bead suspension working solution to each well. Incubate at room temperature for 2 hours with shaking speed around 400 to 600 RPM.
After 2 hours, unseal the plate. Prepare detection antibody working solution first. Transfer 4.2 milliliters of the 1x assay buffer into a new microcentrifuge tube. Add 200 microliters of the reconstituted detection antibody into the same tube. Mix gently. Then, the detection antibody working solution is ready for use.
Place the 96-well V-bottom plate onto the magnetic separation rack for 2 minutes. Aspirate the supernatant with a pipette. Don't forget to change the tips before moving on to the next column. For bead washing, add 200 microliters of the 1x wash buffer into each well. Place the 96-well V-bottom plate back onto the magnetic separation rack for 2 minutes. Then discard the supernatant by pipetting.
Based on the manual, the next step is to add 100 microliters of detection antibody working solution into each well. Seal the plate with the provided sealing film. Incubate at room temperature for 60 minutes with shaking speed around 400 to 600 RPM.
Finally, add 150 microliters of the 1x wash buffer to each well. Ensure the beads are well separated and not aggregated. Put the plate in the flow cytometer, ready for data analysis. Since we are using the 96-well V-bottom plate, select the plate loader from the sample injection mode. Specify where your calibrators and controls are placed. Here, the name of the sample is APC, the special feature of the disc type machine. Since the APC control is placed at the back of the 96-well plate, the number of seconds I choose here is 2 in order to avoid sample precipitation. Then just press OK. Set the position of PE positive control sample on calibrators in the same way. Set dot plot and tell the software what kind of graph I want. The second graph is a comparison between the fluorescence of two colors. I change the x-axis to R660-A,
the y-axis to Y585-A.
After that, I will look at the dot plot of individual fluorescence. And you need to adjust the gain value to find the cell group you want to see. The next step is to determine the background value of fluorescence, and only look at the P1 area in the next few pictures, so change all the events to P1. Then, to set the background value of the fluorescence, we can make some adjustments. Select Acquisition Setting on the left panel, and then you can set the gain value of R660 to 110. To make the corresponding settings, and continue to plot property settings. For y-axis, for x-axis, press Auto, perform a statistic setting. Next step is the stats. Select Apply to all tubes, and on the statistics page, select the Y585-A median. For P1 gate, select Acquisition Setting on the left panel. You can set the gain value of Y585 cytometer to 90. Click the Stop button to stop the acquisition of the current sample and output the results. Finally, right-click the mouse and select Apply Acquisition Setting to all the subsequent testing. After setting up APC and PE positive control, right-click to export all samples to clipboard. For statistic data, we chose parent, population, and events. Apply to all tubes, then click OK. Record can stop receiving data according to the set conditions. Conditions that can be set are below. When I press record, the system will check which of the conditions I set comes first, and it will stop receiving data. Meanwhile, set the flow rate to 100 microliters per minute. For Cal A1, make sure to apply stopping rules for all tubes, then click Start Record. Following, create an auto line segment around the selected population on a plot with APC intensity. Similarly for the y-axis R585-A, click Auto, then Start Record. Export all samples to the CSV file. Now you can collect the results using GraphPad Prism to do the analysis. Select the XY tables with a single Y value for each point. When evaluating data, first subtract the average value of the blank well, which is calibrator 0, from the result of all wells. Next, paste in some data. To analyze data in GraphPad, go to the Analyze button and select a tab called Transform Normalize. Click the Transform option. Then click OK. The next step is do a linear regression. Go to the Analyze button and under the XY Analyses, click the Linear Regression. Then click OK. A new result sheet called Transform of Data1 will be generated. You can see the graph results underneath, and find another results datasheet about linear regression underneath Data1. You should see the correlation of the 6 cytokines quite well. Copy the original sample value from Excel to GraphPad at the same place. Choose Interpolated X underneath Linear Regression of Transform of Data1. Next, to analyze data in GraphPad, go to the Analyze button and select the tab called Transform Normalize, click the Transform option. Then click OK. Now the graph has a linear scale. Now you are able to know the different cytokine concentrations in one unknown sample.